Thank you once again, everybody. Tonight, then we will look at firefighting foams and some of those aspects of controversy and concern and carbon chains and controls. I must say at the outset that I'm not a professional firefighter or even a volunteer firefighter, so I will come at this tonight from the background in occupational hygiene, toxicology and chemistry. Also, I could probably add that across my career I've worked with organisations that certainly have firefighting foams as an important part of their chemical inventory. So we'll sort of come at it from a user point of view as well. Okay, let's get into things. So what we propose to do tonight is a little bit on introduction and about what we're trying to achieve. We'll have a look at firefighting foams and the fundamentals there, and also where PFAS comes into the picture. I'll raise with you the first problem area, which is, well, I'll leave that until we get to it, but also leading in there to the present controversy that's raging around the country. We'll bring in risk communication principles and techniques because they're very relevant, I think, to PFAS as we're seeing it occur at the moment. There's a second problem statement that we'll raise, a little bit to do with the particular chemistry of PFAS that makes it so different. We'll have a little bit on the human health impacts and the issues that go with that. Regulatory direction, there's a mountain of work going on around the country at the moment in this area, and also some recent developments, a few conclusions and a few recommendations. So that's the plan. What I would like to do is feel that by the end of the session we'll have answered these sorts of questions. So firstly, why is it a big issue around the country at the moment? Who is it out there that's being impacted by firefighting foams and PFAS in particular? What is being done? Where are the opportunities there to improve things? And what does good practice look like from a management point of view? So we'll try to get into all those things. So just a few basic things by way of introduction. Firstly then, with foams, of course, they're used for incident response. We hope that that doesn't occur very often, but it does occasionally. What is necessary to back that up is the training component. So this is where a lot of foams have been used over the years to get people ready to go in the event that an incident will happen. There is the question of maintenance of portable and non-portable equipment, and equipment that stores or the equipment that distributes the foam that we have to think about. There's testing of the systems and making sure they're all set, and then there's the waste disposal angle as well. So when it comes to classification, there are a number of ways we can do that. We can classify foams according to the type of fire that they are suited to deal with, and I'll mention briefly Class A fires, but mostly tonight we'll talk about Class B fires, which are the hydrocarbon related fires. Touch on that. The method of delivery, which could be around, we can classify according to aspirated or non-aspirated, portable versus non-portable. There's a few ways of doing that. Then there's the chemistry, the makeup, and here the foams that we'll talk about tonight are those that are essentially fluorinated or non-fluorinated, and there's a number of subgroups within that, and these are the hydrocarbon surfactants and water, but they also contain a lot of additives. So in any foam there's going to be solvents and stabilizers and thickeners, biocides, all these sorts of things that make it a little bit more complex. It's not just PFAS that's in there, there's all these other things that exist. There are many different formulations, and so these other components of the foams that are out there do raise the question in our mind about, well, are there additive effects or multiplying effects, these sorts of things that we might need to consider. And of course the final point there is the foam is only one part of a system, so but that's the bit that we'll look at tonight. So Class A versus Class B, so Class A foams, Class B foams, and fires accordingly, and let's begin by differentiating between these things. So firstly then, the Class A foams are applied to Class A fuels, so things like paper and wood and bushfire situations, some structural fires would be applicable there. can see in the diagram, or you may be able to see, that in that little triangle there, the three things that the fire response people are trying to deal with are heat, fuel and oxygen. And so with regard to the Class A foams, these are usually a mixture of foaming agents and wetting agents, which allow for better penetration. And you can see that's shown here in this figure 3, where the foam is on the top. The wetting agents mean there's more penetration into, in this case, the wood that's underneath here, so you get better penetration, which helps a bit with cooling and a few other aspects of fire control. So these give water foaming ability, which enables it also to cling to surfaces, both vertical and horizontal, which is a good thing there. According to the literature, some of these sorts of foams, compared to water, are at least 5 times more effective than just using regular water. Okay, so Class B foams, where we'll focus on tonight. So these are applied to flammable and combustible liquids. They can be used to both extinguish the fire and also prevent reignition. And you can see a few examples there in the main hydrocarbons where these sorts of foams are readily used. So here's a little bit more about them. So the foam is a primary fire extinguishing agent, and it deals with transport and processing, storage and use ultimately. It is there to both suppress the vapours and also provide visible evidence that things are secure. And of course the very nature of the whole activity is to protect people and protect property. Unfortunately, what has come along and has become apparent in the last few decades is that some of the, particularly the per and polyfluorinated chemicals, the PFAS chemicals that I'll go into in a little bit of detail, have found their way into the environment, and that's what's causing the issues that we're seeing around the country at the moment. So a few of those terms then. PFAS is actually, for those that may not know, PFAS is actually a very generic term, so it's like a family of compounds. The best known of those individual chemicals are shown up there, but the first one then is, the first one, oh, go too far. Okay. Yeah, I should say, so they certainly have a range of properties which make them very suited for products like the ones that I mentioned here, non-stick cookware and so on. So this is why, in a way, they've been very widely used around the world, and they've found their way into the environment. Let me just touch on a little bit of history here. So foams themselves, we can go right back to 1902, when people found that if you mix aluminium sulfate and sodium bicarbonate, you get a release of carbon dioxide, and with water you can produce a chemical foam. So that's fine. That was the sort of early use. But in the same way that we've seen in the last 100 years or so, that when wars come along, there's a great advance in some technologies, and that's also true with firefighting foam. So an example of that was in the 1940s when the Pacific War was on, and aircraft carriers were there to do their job, and in fact they played a vital role in dealing with the war. But aircraft carriers, of course, even in good days when there are planes taking off and planes returning, there's always accidents, there's always a potential for fires to be on board, and fires are probably the one of the number one risks that an aircraft carrier can have. So in the 1940s, it was about that time that the introduction of protein-based foams were introduced, largely because they needed some system to deal particularly if the aircraft carrier and other large vessels were under attack. And that might be with dive bombers and torpedo bombers, and later in the war kamikaze pilots that would want to blow everything into smithereens. So that was a development that occurred at that time. So protein-based foams. The foams, incidentally, were taken meal and then mixed with various chemicals and foaming agents and water to produce that foam. Then by the 1960s, there were some developments to add fluorocarbons to the mix, and it was found that this was the so-called fluoroprotein foams were more effective than what preceded them, and so they came into being. But then in the mid-1960s, with the Vietnam War, again there was a technology, there was a need for better technology there, and again there were aircraft carriers involved in those early trials. Here, the reason why that got a bit of profile was because the jet aircraft that were now in service were able to carry 10 times the bomb load and 10 times the fuel load. So you can imagine these aircraft and the potential risks of fire, and how important the fire control role was on those aircraft carriers. So by the period of that's shown here, the mid-1960s, we see the first emergence of what are called aqueous film-forming foams, AFFF. Now, as time progressed, it was apparent in some industries, and oil and gas is one industry, where the operation occasionally encounters what might be called polar solvent materials like methanol. These things come up. When they come up, they effectively destroy the foam that's been applied. So they take the water out of the foam actually collapses, and it's fairly ineffective, the foam blanket. So what developed at that point was the so-called alcohol-resistant foams, and these are particularly applied where there's both a hydrocarbon involved and also the potential for polar solvent materials. Now, by the early 2000s, what had happened is it became obvious that some of the PFAS chemicals were finding their way into the environment and were being picked up all over the place. And so the production process itself was changed from an electrochemical process, fluorination process, to what's called telomerization process. And that occurred, so that was a change in technology built on what was being picked up in the environment. The other thing that came along, not so at around about the same time, were the development of fluorine-free foams. These are basically hydrocarbon surfactants that have some solvents and also some complex sugars in the mix, but they provide another alternative. So this is from the Fire Protection Association of Australia, and essentially they point out that how they operate. They cool the fuel surface, they coat the fuel so they prevent contact with oxygen. They resist mixing and breakdown, and this is talking again about those polar solvents that are sometimes encountered. They retard vapor release from the surface, they control the fire spread and progressively extinguish, and they provide some protection from reignition. So they do a lot of good stuff there. So where are the firefighting foams? Where have they been used, or where are they being used? Largely, this is not an exhaustive list, but it's some of the main ones. So we start off with the military air bases. I'll come to them in a second. But civil airports are there. Wherever there's been fire training, there's the prospect that some of that foam may have got away and got into the waterways and eventually found its way into the environment. So we need to look at that, think about that one a bit. And then there's a variety of where fuel is handled and transported and stored and loaded. There's the offshore and onshore element of oil and gas. There are ports, chemical storage facilities, and then refineries. So again, that's only a sort of a partial list of where you might expect to find foams, and potentially find some foams that may have got into the environment. Okay, so we come now to the foam types, and essentially there's the two types, those that contain fluorinated surfactants and those which are fluorine-free. The bits that are there, I've already mentioned the AFFF, the aqueous film-forming foam, one of the early ones, and then the development that provided some alcohol resistance for certain applications. There's the film-forming fluoroprotein foam that was developed, and then there's an alcohol-resistant one, and then there's a fluoroprotein foam. So there's a number there. There's no one foam that does everything, otherwise everybody would just have one foam. There's a lot of different applications involved here. So let's have a look at this first problem statement. So what we have is that some of the foams have found their way into the waterways, surface water and groundwater, introducing chemicals that have this characteristic called PBT, which means persistence, bioaccumulation and toxicity, PBT. And they're also highly mobile, so some of these chemicals can find their way into all sorts of places where you don't want them to appear. Now, unfortunately, and one of the things that underpins the controversy is that some of those waterways are relied on by local communities, and some of them use them for domestic consumption, as well as water for maintenance of livestock and crops and so on. And here we have the nub of the problem. In some communities there are some very high levels of concern, anger and discomfort about things like perceived human health impacts, animal health, food consumption risks, saleability of produce, local produce, impacts on property values. All these sorts of things are actually out there at the moment. And so what that's led to are various claims that we're seeing in some sections of the press about compensation and class actions, government inquiries, risk assessments, all this sort of stuff is going on at the moment. So here we come to some very high-profile examples. The first one is the Williamtown Air Force Base. Williamtown is about 175 kilometres from north of Sydney. It's surrounded by a high-risk aquifer, a source of potable water for the local community. And I'd have to say, in terms of PFAS and the controversy, this would probably be ground zero in Australia at the moment in terms of where all the tension has been over these last several years. So that's at Williamtown. It's subject to a class action at the moment, along with the other two bases that I mentioned there. The second one is the Oakey Army Aviation Centre. That's in Queensland. It's about 150 kilometres west of Brisbane, and it's an issue around groundwater contamination that's occurred within 150 people. The third one that's mentioned up there is attached to the Tyndall Air Force Base in the Northern Territory. It's about 15k outside of the small town, or the town of Katherine. And what's happened here is what's thought to have happened there is the area used for firefighting training, the foams and so on have got into the groundwater and surface water and eventually found their way into the Katherine River, and that's where the issue is at the moment. So there's some pretty big ones going on. Oh, the Department of Defence, by the way, with the last one, are looking at a system of recovering some of the groundwaters. They have some water treatment things that they're going to do, and then they're going to re-inject the water back into the groundwater. So that's all happening at the moment. What I would like to point out is that there's been an awful lot of, as many of you would be aware, an awful lot of media attention to PFAS, particularly from the ABC and the Fairfax media. Four Corners did run a 45-minute special back in October 2017. Erin Brockovich has been involved. They keep bringing her out, together with teams of lawyers, government agencies, politicians always have something to say there, and many others. And PFAS, the PFAS issue at Williamtown has features that some sections of the media actually salivate on. Things like alleged cumulative effects, including cancer, alleged impacts on children, prior knowledge by the authorities, perceived secrecy, impact on land values, water access and water use, capacity to borrow. All those sorts of things get wrapped up into the issue, so you can understand why people are so conscious of this particular issue. So what do we see around the place? the focus has largely been on the Department of Defence, almost entirely, with regard to legacy foams. There's been very significant interest in the issue. Some 90 sites around the country have been identified as locations of interest, and the big question then is what does this mean for past users of foams or present users, and in both the private and the public sector. You can see some of the signage that's out there in some of these areas. This particular slide shows Western Australia. There are 14 sites, I think, at the moment that are under investigation, and these are largely to do with Department of Defence sites, either RAF or Navy, or fire training sites used in the past. Bulk storage sites are in there, and also civil airports. I might add, in looking at this particular issue, the people that are looking at the class actions with those 3 defence sites are also thinking about WA and Victoria, apparently, so we'll have to see what comes out of that. Okay, Captain's Lagoon is in near Jervis Bay on the south coast of New South Wales, and this is the sort of signage that people are seeing now, precautionary signage around consumption of seafood. Here's another one. This one's Wesley Training Centre in New South Wales, about 30 kilometres from the Sydney CBD. It's basically a training facility, so fire training there, and there have been a variety of human health and ecological risk assessments being carried out. However, from what I can see of that, the criteria have not been exceeded, but you can see the potential here with activities like training occurring here. There's the community down here. Looks like there'd be sure to be some type of waterways down here, so it's got that potential for some of that issue to be there. Now, this is a little slide to show some of the players that are out there in this particular activity. So we have the manufacturers and suppliers. They have a role and an interest, of course. There's all the users that are there, the federal government agencies, the state government agencies, even local government have an interest. Local communities, the federal parliament, and we've recently had a Senate inquiry into the Williamtown matter at a Senate level, politicians, the media. We have HES professionals, university academics, lawyers are very much present these days, the wider public, and then activists, and then Erin Brockovich over here on the right-hand side. She seems to pop up everywhere that these issues occur. So now the principles of risk communication can be applied wherever there are high concern, sensitive or controversial situations. It's certainly risk communication is something that's accompanied me right through my career, and refinery emissions and low-level radiation and dust and water quality and asbestos and all those sorts of things are part of the risk communication scene. But it's probably, and there's a definition up there, it's probably well suited to health-related concerns in particular, and I'll mention in Western Australia a few years back, and he's been able to share his knowledge on risk communication. So let's have a look at how risk communication principles and techniques might apply to PFAS. The first thing is that the fundamental goals for risk communication are firstly to increase trust and credibility, and that's done in large part by increasing listening, caring, empathy type approaches. Some organisations even call that active caring. Then there is the goal to increase knowledge and understanding, and that is to produce a better informed workforce, officialdom, and also public, to increase the likelihood of wise decisions being made, and also to produce an appreciation of the resource limitations and difficult choices that may be involved in this. And then thirdly, resolving conflict, and this is all about achieving a win-win type of situation if possible. So what Cavallo and other researchers, and there's a mountain of work in this area, that shows us that in these very difficult situations where people are angry, upset, or concerned about something, there are three primary barriers to risk communication. communication. And these three are mental noise, distrust and negative dominance. So what we know, and all the research is telling us, is that when people are angry, upset or fearful, based on either perception or reality, it's an issue. And the studies do show us that only about 20% of the message is actually received. It literally goes in one ear and out the other. So it becomes a huge barrier in regard to attention, retention and understanding of the messages that are being attempted to be conveyed. The second point there is that when people are upset, angry or fearful, distrust levels are high, and people will question the integrity, the competence and the honesty of the organisation, and also the people that represent the organisation. And then finally there, when people are angry, upset or fearful, negative thoughts and perceptions absolutely dominate, and this is the reason why skilled negotiators avoid words like no, not, never, nothing, none in their communications. And there's a whole body of science that supports this particular thing. Now, I'm not going to go into that for much more detail other than to pick out a couple of things of interest that I found that I wanted to raise with you. Firstly, we have some PFAS related images from the internet. The first is a public meeting at Williamtown, I believe. The second one is a public meeting at Catherine. And the third is a public meeting at Williamtown as well. Two things I'd like to touch on. Firstly, control of body language, and secondly, the town hall scenario. So what we know about body language, and the research backs this up, is that people judge the messenger before the message. Secondly, they judge the messenger primarily in terms of trust, and that non-verbals provide 50 to 75% of the message content. They are noticed intently by the audience, and they tend to override verbal communications. So when you look at that bottom right-hand image there, and by the way, that's not our premier on the right-hand side, the gentleman on the left-hand side I just wanted to focus on, and you can see that he's got a certain look there. What would you say, what would the message be if this was an angry, upset audience in a difficult situation? How would you perceive the fellow on the left-hand side there? Maybe a little bit detached from the whole thing. He definitely doesn't want to be there, that's for sure. So it's an issue around body language and the control of those things. But the second thing I wanted to raise is that on the so-called town hall meetings, now sometimes you get carried along with these things, and town hall meetings are the only way things are going to be done. But there are better ways of communicating effectively, and town hall meetings are sometimes not the best choice, but lots of downside in terms of actually getting the message across. But what is preferred is what's called the open house approach, and that's more this sort of thing, and Cavallo and others have done a lot of research on this, so that you have the various stands and all the interest areas. You have your workforce or your community come in and go to those things that interest them. You have layered information from the basic points to maybe the fact sheets, and then down below that more information if you have a water expert or somebody like that wants the additional information. So these are the things that are part of that scene, and it can be applied. So some key thoughts here then. When people are stressed or upset, they do have difficulty in hearing, understanding and remembering. Most of the concerns and questions of upset people can be predicted in advance, so that applies to both the workforce and the community. If you go into those situations, make sure you've thought through those things. The risk is multidimensional. The size is only one of the dimensions, and then there's a whole lot of things you can do to address these other issues that are worrying people. Okay, so problem statement B is really about the carbon-fluorine bond, and it's the strength of that bond. The carbon-fluorine bond is the strongest bond in organic chemistry. It takes high temperature incineration to destroy it, to destroy unwanted foam, and it's that bond that gives rise to those physical, chemical and toxicological properties. It's the source of the PBT, the persistence, the bioaccumulation and the toxicity elements there. So what we have in terms of complexity is 3,000 PFAS chemicals, homologs and intermediates, transformation compounds are there. I should say on the PFAS chemicals, about 600 of them have actually been used in foams of various kinds. So there's a lot of chemicals there. We like, as human beings, to simplify things if we can, so we've sort of identified a few main ones there, but there's lots that are out there. And so there's these intermediates and transformation compounds. Another complication is some manufacturers are very reluctant to disclose the ingredients in their formulations, citing confidentiality and these sorts of things. So that can sometimes be a bit of a tricky one. I'll make some more comments about that when we come to safety data sheets in a short time. But just in terms of profile, yeah, it's a big issue out there. There are a lot of government requirements coming through that may have an impact on the operational side of foams, but there's a whole heap of unknowns and uncertainty that complicate things. So we've dealt a little bit with PFAS, PFOS and so on, and PFOA, perfluorooctanoic acid. The other one I think would be such a difficult acronym, it's probably better just to call it perfluorohexane sulfonate. And I will also mention C6 foams and C8+, so these are the shorter chain fluorotelomere foams and the longer chain ones based on the length of the carbon chain. Now at this point we probably should, this is the most complex slide that I've got here, and I thought I might try and explain how it works by reference to a common dishwasher detergent. All right, so a dishwasher detergent has a couple of things. Firstly, it has a hydrophilic head, a bit like this, and a hydrophobic tail. And when the grease particle comes along, the tail likes fats and oils and greases, so it attaches itself to the grease, and thousands of these do the same thing, so that eventually that grease item is then washed down the sink. That's the end of that. So in a similar way, when we come to talk about polyfluorinated compounds and perfluorinated compounds, which are the basis of PFAS, we're talking about something similar. What we've got here are, firstly, let's go through this. So these little atoms represent different things. The green ones mean fluorine, the grey means carbon, white hydrogen, red oxygen, yellow sulfur, and so on. So we've got the carbons over here and the fluorines. And then we've got in the polyfluorinator, we've actually got this other little thing. It's called a spacer. And that's two carbons, and it's also got some hydrogens. And that separates this functional group from the rest of it. So this is the hydrophilic head, and this is the hydrophobic tail, basically. And so there's a certain convention in terms of how these are named. Over here, so that's polyfluorinated. Perfluorinated, there's basically just the carbon chain, the tail, and the functional group up here. That's a sulfonate, basically. So what happens is the similar sort of thing. The hydrophobic piece attaches itself to the oil or the hydrocarbon, and this one sits, the hydrophilic head sits on top of that. So it separates the hydrocarbon from the air that's above and gets this film formed on the surface. So that's probably the simplest way I can explain it. There are other functional groups, carboxylates and amines and lots of other stuff in there that give it a bit of complexity. So the limitations that are there are firstly currency of sheets. Sometimes out there you find sheets that are out of date. The 5-year limitation is there. I did do a bit of a review of some safety data sheets that are out there in industry, and some of them were out of date, which is something that has to be managed properly. Sometimes the environmental information is very limited on some safety data sheets. Sometimes species are quoted for toxicity testing that aren't appropriate. Sometimes there's absence of toxicity information on some of the other things that are present, like those stabilisers and biocides and preservatives and so on. And then one big one that's been called upon, or the government in various parts of the country has asked for more information on the whole mixture as distinct from bits of it. And so there's quite often that's a tricky one to get hold of. And some sheets have more of a focus on short-term effects only. So there's some of the challenges that are out there. So, key facts on the matter. Firstly, PFAS is everywhere. It's ubiquitous. It's in the environment, plants, animals, and the human population, not only in Australia but around the world. There are many different types, and there's quite a lot that's not known. There are potential links with serious human health effects, which I'll get to in a second. High profile, as we've seen. Regulatory change is coming. And also, just make the note here that one of the things that is happening in some of these communities that people are being offered as a voluntary thing, blood testing, but the medical authorities make it clear that this actually provides very little assistance with prognosis, diagnosis or treatment. It may have a value in looking at communities as levels come down over time, but limited value there. So here are the human health effects that are out there in the literature. These are the various bits that are claimed. You can see there's a whole lot of stuff there, and that's not even an exhaustive list. There are other things like asthma, endocrine disruption, impairment of reproductive systems, all these sorts of things come into play. But there is a lot of inconsistency with the information, with the studies that are out there, and I'll come back to that in just a second. So regulatory direction and guidance. Now, there is a lot of stuff happening, and a number of the regulators are present in the room tonight. But certainly at the national level, the heads of the various EPAs, the HEPA if you like, have now signed off on a PFAS National Environmental Management Plan, so that's out there as a resource. The Australian Government Department of Health has had a lead role in this whole matter. Safe Work Australia is involved. NICNAS, that's familiar to many people in the room here, the National Industrial Chemicals Notification Assessment Scheme, has had quite a bit to say about PFAS over the years, and also NOPSEMA is involved as well. There's a lot of stuff happening around the country from state to state and territory to territory, but I just wanted to single out the Queensland Department of Environment and Heritage Protection. They have been very active in what they've done with their policy statements and so on. And in fact, the WA department here, DEWA, the Department of Water and Environmental Regulation, actually cooperated with the Queenslanders in some of that policy development. So that's Queensland, then WA. We've got the three key departments that have been pursuing this matter over here. So at the national level then, we've seen a Senate inquiry carried out, mainly focused on Williamtown that I mentioned, but there's a whole lot of recommendations that are coming out of that, and most of the focus again is on the Defence Department. We have testing and assessment, so the Australian government's response to this issue is they have offered voluntary blood testing, epidemiological studies have been offered, counselling services, mental health support, all those sorts of things are part of that. There is an expert health panel that has been set up, and that's been beavering away for a while now, looking at all the international information and what's been generated within this country and trying to provide good advice on how to deal with the matter. NICNAS has a fact sheet. I'll just come to that in just a second. It's got some pretty standard stuff in there, some good stuff I think. The PFAS National Environmental Management Plan that's shown here came out at the beginning of last year. What has emerged are health-based guidance values, and these have been put out by the Australian Department of Health, and they provide tolerable daily intake. A very important bit of information. So what this is saying is that these are the levels that can be tolerated, and it also provides limits for drinking water, etc. So just to cover off on that one, health-based guidance figures. So here we have a number of the factors. Firstly, the tolerable daily intake in micrograms per kilogram of body weight per day, and there's a figure here for two different categories of chemicals. Drinking water quality, again in micrograms per litre, is shown. You can see that PFOA is not seen in the same PBT perspective as the others. And then there's even one there that's been now published on recreational water as well. So there's a heap of stuff happening in that area. The Food Science ANZ has done a lot of the work on this on behalf of the Department of Health, and the PBT characteristics are very much an explanation for these different levels that sit up there. They are considered protective of human health, and they represent the amount that may be consumed on a regular basis over a lifetime, according to our medical authorities and others that have investigated the issue. So the fact sheet here, this is what NICNAS has had to say about the issue. Looking down, it looks pretty logical to me. PFAS, PFOA related chemicals should continue to be restricted to essential uses only. PFAS-based firefighting foams used for essential application, not for training purposes. That's an important one. Industry should seek to phase out items of concern. Existing stocks should be disposed of responsibly. Importers and users should be aware of international developments. And also, importers should be looking at less toxic and non-persistent alternatives. And then up-to-date information should be provided on labels and SDSs. So when you look at that, and then you look at what they said in 2003, there's not a lot of difference actually. So NICNAS have been on this one now for a long time, and they've been giving pretty solid advice out there on this. So we come now to recent developments. We're just getting towards the end here. We'll just summarise where things are at. I particularly wanted to mention Queensland with their new operational policy, and it's featuring pretty much a ban on future use of foams that contain PFAS and PFOA. It requires a phase out of existing stocks. It features the precautionary principle. Now, for those that may not be aware of that, that's something that comes out of a judgment from the New South Wales Land and Environmental Council in 2006. Chief Judge Brian Preston was involved with that one. It's essentially saying if you're not sure about something, if, for example, you've got short-term toxicology information but you don't really know about the long-term stuff, well then don't assume that it's all okay. That's the simplest way of putting it. It also calls for the use of the C6 purity compliant foams, which provides a suitable definition of exactly what these things are. South Australia have been proposing bans, but they're in consultation. Here within Western Australia we have guidance material that's been issued a couple of years ago. There's that work with Queenslanders that I mentioned, and again there's a recommendation for a phase out of PFAS of concern. So when we talk about purity compliant, this is how it's been defined. So you can see here there are some limits applied for the different categories here. So this gives us something to work with. So in the past this has been a little vague and up in the air. Now there is a figure that can be used, and I think this opens up the opportunity for a dialogue between the users and the foam providers and the government agencies in terms of working out something that can be done in this area. So the big conclusions here are the PFAS National Environmental Management Program is now fully endorsed and is a principal use for anyone that's been involved is being involved currently with foams or is interested in past use. There are definitions available for acceptable levels in foam, so that's a really good development, I think, and that opens up the way for these dealings and interactions. I think it'd be fair to say that regulatory controls in WA are likely to be similar to those introduced in Queensland. We sort of seem to be heading down that track. There seems to be a pretty strong move towards the C6 purity compliant foams and also fluorine free. Now this is an important one. With regard to all those alleged impacts of PFAS on human health, the position of our health authorities, both at the federal level and the state level, is that there are a lot of inconsistencies with the data that's out there, and that chance bias and confounding factors can't really be excluded. So at this stage, that's the view that's taken. However, it is accepted that PFAS has negative impacts on certain animal species. So, what does good management practice with PFAS and the foams look like? Firstly, I would think if it's not already been done, it should be done, that PFAS-containing foams should not really be used for firefighting training. Use other materials if fluorine-free or whatever's available. Minimise the foam use for fire equipment testing, and then implement something that makes very good sense from an occupational hygiene point of view. Contain, collect, dispose strategy, and try and keep things together. Impermeable bunding, containment, those sorts of things that all occupational hygienists and HES people present in the room would recognise as making good sense. So the principal recommendations for management of PFAS then, firstly, I think there's value if you don't know what's in your groundwater to actually, but you do know that the foams have been used in the past to actually do a little bit of sampling and establish what's there. If you don't do it, the question may be asked and then you're sort of caught flat-footed, so it would make sense to do that. I think it makes sense also to have a management plan and covering some of the aspects that are mentioned up here, to have a plan that defines who does what in organisations and in regard to foams, covering off on selection and procurement, those purity requirements, and some assurance from the vendor, the supplier and the manufacturer, about the composition and whether that meets the requirements to be applied there with purity compliance. Commissioning your new equipment should be covered in the management plan. Application of foams, maintenance, training, foam storage, foam disposal. All these are good things to have under control. So when organisations find themselves with legacy foams, something that's been used in the past, the suggestion here is to purchase quality C6 purity compliant foams or fluorine-free foams when the foam inventory replenishment is required. Continue to use remaining stocks until that's finished. When practicable, take steps to segregate the new purity-compliant foams from legacy, and put in place measures to ensure that the purity-compliant foams are used in advance of legacy foam during a fire situation. That would also make sense, I think. Assessing the need to clean storage vessels and delivery system when changing over. And then here's a big one, work together, link up with like-minded organisations that are facing the same issues, and pursue some initiatives with them and with manufacturers and regulators on legacy foams and some of these other purity-compliant foams that are around, and fluorine-free foams. So that sort of takes us through to a little bit of a snapshot really on foams. I think we've tried to answer those 5 or so questions right at the beginning and cover off in terms of what might be done in terms of management of these things. So that takes us to the final bit. So we'll take any questions if there are any there.